Let's jump in. So, my name is Ron. I'm a developer advocate here at CelerData. Today, we're going to be looking at StarRocks in financial services, specifically exploring strategies and recommendations for building a modern financial data warehouse designed for real-time analytics and business intelligence through the lens of equities trading. That will be the example we'll be walking through. We're going to cover some high-level use cases and then walk through a portfolio risk demo powered by StarRocks, showing how different features of StarRocks, like streaming capabilities, materialized views, and external catalogs, can give you the big picture. There's going to be a demo GitHub link available at the end. And as a preface, the catalog names and the database names of the demo have been removed for a reduction in any confusion we may have as I'm talking about the slides. But otherwise, let's jump in. So as for the agenda, I'll walk through the architecture very briefly in the beginning, just to give everybody an idea of where we're heading in the presentation. The trading problem and a lot of the problems that traditional warehouses have in the context of financial services, and then we're going to discuss some of the data models that everybody is familiar with, and what are some of the features in StarRocks that drive us to success around dashboarding and modeling tick level data. So a little bit about me. I spend most of my time educating and empowering developers within the StarRocks and Lakehouse ecosystem. I previously worked in financial services as a data engineer on the sell side at an investment bank prior to coming to StarRocks and CelerData. A lot of my work kind of spread around the stack, but a lot of it was focused on containerizing, warehousing, and modeling real-time tick and streaming. So from venues like TradeWeb, DealerWeb, Market Access, Bloomberg, for those of you who may be familiar, across a variety of desks. So rates, credit, mortgage-backed securities, kind of encompassed a lot of different fixed income products. So likewise, a lot of my infrastructure was based on Java, Protobuf, gRPC, Kafka, KDB, another database, and a lot of your run-of-the-mill AWS tools. So that's a little bit about me. There's a QR code there as well if you'd like to connect on LinkedIn. So going into high-level architecture of what I'm going to be discussing today around the portfolio risk dashboard, this is going to be an example of a federated querying workflow for dashboarding. So from left to right, StarRocks is sitting behind a Grafana dashboard, and that is delivering changing P&L information. That's the theory. StarRocks itself will be in shared nothing mode, split into two data catalogs. And as I go further in the demo, this will make a little more sense. The default catalog that's storing data on an EBS volume, and then the database we'll call real-time DB sitting under that. And then real-time DB will have two pertinent real-time tables, prices and trades, and those prices and trades tables will be fed directly from two Kafka topics. The prices topic and the trades topic via routine loop. We'll talk about this a little bit later. So this is the federated portion, and then the actual separation of storage and compute where we connect the Iceberg catalog. So we have capabilities of hooking up externally to Iceberg. That Iceberg catalog will have IBDB, or Iceberg DB for short, and that catalog is going to have a lot of our static data. So things like books, reference data, traders, the mappings for those books, and the books and traders that are associated on each of the books. But that's kind of just like a high-level overview of what the architecture is going to be. So what is the trading problem, or a lot of issues that regular traditional warehouses have? Well, I mean, let's walk through an example. So, say it's sometime in the afternoon. Let's pick a time, like 2:47 p.m. to be specific. And the Fed announces some sort of rate cut. It's very speculative these days, but let's say they do a rate cut. And within seconds, you have increased order flow because models and traders are reacting to this new information. But your infrastructure isn't really built for it. A lot of folks on the street are still leveraging a lot of the same batched and monolithic infrastructure that they were using 15 years ago. Some things we can't really avoid just because the regulatory industry is still behind in a lot of ways. So, for example, trade settlements and the clearinghouse, you know, T+1, T+2, T+3, and so on. Those settlements are often batched overnight or days afterwards. And a lot of mortgage accrual systems in banking software still rely on uh, mainframe architecture upstream. A lot of them are conscious old decisions that still have stayed, like ETL jobs that make next day reporting the norm. A lot of it is stuff that somebody said, hey, this works, but it was a long time ago. Say manually parsing CSV files from point A to point B to point C, large cache buildup. Um, let's say you have some ETFs and you have some sort of portfolio manager doing a recall at the end of the day. There's files that are being read in super archaic ways still, and kind of coupling each of these siloed and fragmented components and slowing down your whole time to production. It's kind of inevitable. And so the result of that in our example, well, we'll probably living with a lot of the same stale positions and prices or erroneous data that's the result of this tech debt. So ultimately, your analysts are probably making, with what they believe are informed decisions, actually dated decisions that can sneak in through the cracks. So, what are some of the pillars of warehousing and architecture that we do want to observe in an ideal environment? What is that? Well, the first one is that data has to be available to users within seconds or minutes of it arriving into the system. And of course, that kind of depends on the use case. In our business intelligence example, receiving updates by the minute is pretty standard if you have some sort of dashboard. Um, you know, of course, when you go into situations of high frequency, you might need really fractional information. But for most cases, when you have somebody on the desk trying to gauge P&L or information on, say, the risk in this example, minute by minute is usually sufficient enough. And a lot of refresh windows on BI tools don't even go into that. But markets are changing. We have to recalculate constantly. The second one is that our data needs to be accessible, reliable. They shouldn't be wrangling raw schemas or complex queries to answer really basic business questions. There should be some governance, some identity policy set in place. Um, the quants will have different access, but desk quants will have different access than the software engineers working on the infrastructure, right? Third, kind of the end, users expect insights through in-house dashboards like Tableau, Power BI, Metabase, Grafana with the familiar faces, and being able to use those user-friendly tools that people can connect to and federate with other applications just makes people's lives easier. People want usually the simplest means to an end. And they expect those BI capabilities. So those are just some of the pillars relevant to us. Jumping into the data model. So, what is the data model that we're most familiar with in trading context? So, jumping over to this, it usually looks something like this. This is usually the who, what, where, and why of data on a desk. So, the foundation of a lot of our data begins with reference data. So, that table on the right hand side, and that kind of gives context to our instruments being traded. So universal identifiers like ISIN and QSIP go just beyond tickers, say like an Apple or Microsoft ticker. Additional fields like description, exchange, currency are very essential to understanding what it is and where it is that we're trading from. On top of this kind of sits our trade layer on the extreme right side. So that's actually capturing what was executed, symbol, price, quantity, order IDs, timestamps. And then those trades are organized into books. So that represents strategies, desks, portfolios. And then the prices table itself adds its own market lens, right? So trade shows what happened, prices show the current valuation. And then usually there's a mapping between mapping between books and traders. In this case, I called it book traders to show who is on what book and what strategy is being executed on what desk. So together, reference data, trades, books, traders, and prices form the core data model of financial institutions. Let's talk about some of the features that StarRocks has and provides that can drive us to success, knowing what we know and the pillars that we want to achieve um, in modern warehousing with financial information. So it starts with data modeling freedom. When modeling market data, not every single table is equal. Prices are moving fast, and whether you care about every tick or just the latest snapshot, that's going to drive your schema choice a lot. On the right-hand side, let's look at this table. So I have my ticker, which I've referred to as symbol for general purposes, a price timestamp, and a price. So it's a fairly simplistic view of a price table. Now, since I have a fire hose of tick data, I have the ability to create a duplicate key table. So StarRocks allows me to create this compound key on symbol and price timestamp, and I can capture all the ticks, even duplicates, while keeping time filters efficient and lean. And then going one step down, I can partition by day to prune my queries and filter them. So when I start building out this materialized view and querying it, if I'm somebody who's querying by the day a lot, that's going to be very helpful for me. I could also partition hourly or by the minute. It just depends on what my partition retention policies end up being and what we want to keep. And then I get one additional level of data granularity by distributing by hash and bucketing my symbols to balance the load across my partition, so I don't get any hot zones or data skew, right? That's the last thing we want, especially when we have lots of different symbols. And then at the bottom, notice I have the colocate property set. So with colocate, if I specify multiple tables with the same colocate group and maintain the same bucket policy, I can get very cheap, fast joins because when I specify colocation, StarRocks is going to ensure that a lot of the related data sits on the same partition, so there isn't any additional node shuffling that you may see on other join types behind the scenes. So this is a very great capability that we'll see a little bit later on in the presentation. Now, if we only cared about the latest price, we could also use a primary key table, right? So that could be a snapshot, getting our maybe if we want the most recent price, and then we wouldn't get any duplicates. So the trade-off is kind of simple. We could have gone for the duplicate key if we wanted, the full tick history. Primary key would be good for snapshots, but nonetheless, we get a lot of flexibility with our data modeling here. Now, for the next feature, I'd like to set the problem up first. So for the sake of example, let's consider this. So on the left-hand side, I have a very mathematical definition, but it gets simpler as I go right. Let's consider VWAP for a portfolio, or volume weighted average price for just the buys on a portfolio. So this is not VWAP on a market or any short positions. Let's just consider the volume weighted average execution price on the buys for every security on all the portfolios. So very simplified example, but realistically going from left to right, I'm asking, what is the total money I spent on my buys, dividing that by the total number of shares I bought. That's basically the question I'm asking. So what does that mean behind the scenes? Well, that means I'm going through all of my trades tables, grouping book by book, adding up all the products of quantities and prices, and dividing them by the quantities of every book I have. And I'm kind of recalculating this constantly. So in a lot of situations, you probably see a messaging bus and a lot of tightly coupled integrations that would handle this upstream. But nonetheless, this is hundreds of thousands, if not millions of calculations. Now we can kind of directly feed a lot of this stuff into StarRocks. So this is where asynchronous materialized views come in. These views kind of act like pre-computed shortcuts. So instead of repeatedly running the same heavy query and consuming system resources, we can kind of store the result set and have it refresh automatically as new data arrives. So the payoff is huge on this because a lot of these sub-second queries, I'm able to achieve sub-second queries on a lot of these complex aggregations. So on the right-hand side, if we notice, here I am creating my materialized positions base. This is going to be my base materialized view that refreshes the weighted average price for my portfolio. Then I can come in with a bucketing policy with hash, but I could also opt for a partitioning policy. It just depends on my retention policies. And then I have the refresh async segment. So that's going to refresh our materialized view whenever our base table changes. So I could adjust that to whatever I want. It's flexible. I could do it in 60 seconds if that's the default refreshing scheme for a lot of dashboards like Tableau. It's kind of up to us as the engineer. And then I have my individual segments. You'll see the sums to calculate net quantity. So that's just negating quantity when it's a sell, keeping it positive when it's a buy, and the actual average price calculation. And on the right-hand side, I've taken this materialized view and my previous prices table that I just showed on the other page to have a side-by-side. So, I mean, this makes sense, right? I could have my live price refreshing on one column, and then the other column, I actually see what I bought that security for. So notice I'm leveraging at the bottom the co-location group on Symbol. So how am I doing this? Well, each of these tables have the same bucketing policy, so the associated symbols are going to be living on the same partition, and I'm also joining on the symbol. So we get that co-location, but we also get these additional layers on top of that that make materialization very modular. And then we also have query rewrite. So say I wanted to hit the base table. If the domain of my query hits the base table that this materialized view is built on, if the domain of it contains this query, I can easily just, StarRocks will reroute that query to the materialized view. So we save a lot on latency and freshness, or latency and speed there as well. Some other features that we have, with external catalog support. So a lot of financial institutions usually have reference data managed somewhere, sitting somewhere static. This kind of allows you to query your data in place without any additional ETL. So your data can live separately on, say, like Iceberg. So looking at this example, we have StarRocks in the center with an internal catalog on the left where the data is stored, but then an external catalog connected and managed by, say, Glue or Hive. But our external catalog support goes far beyond that into Hootie, Delta like JDBC or Pymon, for example. In this example in the middle, I chose Glue just because it kind of sits nicely within the ecosystem. But on the right-hand side, we can see how easy this is. So all I have to do is specify the catalog type I'm interested in, the authentication method, say like IAM role or instance profile, and that's it. But I can easily connect to an external catalog, and I'm kind of free to query it straight away. So this gives us a really good unified view that combines our static and real-time data. And then the next feature, which we have, is routine load, allows us to ingest directly from data streams like Kafka. So tick level data is usually going to be on maybe like a messaging bus or an external platform. But when companies are migrating to using Kafka and Flink, StarRocks can talk to it directly. So routine load can split your ingestion into these mini tasks. And these tasks can be assigned to your topic and handle any back pressure, retries, schema evolution. So your data can become queryable, and you can parallelize those multiple streams. So in my case, I set it up for prices and trades, and the syntax is super straightforward too. I could specify the partitions, my concurrency number, which allows me to allocate the number of tasks that I want to use, and really you don't have to involve yourself in any messy upstream streaming pipelines that force you to integrate on the back end. And then we kind of get to this cumulative materialized view where we have our positions and P&L in one panel. Here I'm selecting my books, my descriptions, kind of joining everything together, kind of a high-level overview. And I'm calculating that unrealized P&L, right? This is kind of the final view. I've combined all the things together. We see all the Iceberg components. We're joining on symbol, book, trader ID. And it's a pre-computation, so it's modular, it's query rewritable, it's easy to maintain. And because we've layered our materialized views from previous stages, it's very easy to work with. So this is kind of the culmination of the Iceberg component, the routine load, asynchronous materialized views. And lastly, this kind of leads us to a slew of business intelligence capabilities that can sit on top of that final materialized view. So StarRocks can leverage tools like Looker, Tableau, Power BI, Metabase to garner those insights. And the key advantage here is that the tools can almost directly query StarRocks using JDBC or standard SQL, so you don't have to go reinventing the wheel with any weird API or connector to talk to it. Users can kind of start querying StarRocks straight out of the box if they'd like to. So on the demo on GitHub, I opted for this view. So this is an example of the view using Grafana, just given its ease of use and the fact that I can easily copy paste the JSON template for distribution on GitHub. So it's that's kind of the reason why I chose. Grafana, and it's open source. So always cool to use open source tools that integrate with StarRocks. But otherwise, kind of to recap, this was our architecture, right? We covered some of the issues, some of the pillars of modern warehousing, some of the problems, but more importantly, the features of StarRocks. So, materialized views, external catalog integration, business intelligence capabilities, and how StarRocks can kind of be your one-stop shop for splitting your financial services information and modernizing your stack. So that is pretty much it in regards to the session. If you want to try kind of what I spoke about yourself, uh, feel free to do so. The GitHub link is there on the page, and these slides will be distributed as well later. Feel free to join our Slack channel if you haven't. Connect with me on LinkedIn if you'd like. I'm always looking for feedback. Give me feedback on this session, or just have any questions about